Let's talk about story problems. In these examples and in this 2.2, you're going to convert story problems into equations that you can then solve. So we're building off of 2.1, solving equations, but first we're going to have to come up with what the equation is. So in story problems, we're obviously dealing with words, and so it's helpful to know what words have to do with addition, subtraction, multiplication, and division. So let's talk about some of those words. As far as addition, you might see the words increase or add. And you can probably think of some other words that mean addition. Subtraction, we actually have one in example 1, decreased. So that would be an example of a subtraction word. So decrease, maybe make some notes of these sorts of words on some notebook paper, or take some notes somehow. Subtract. And then, as I went through the examples, I saw one where it was dropped. All right. On to multiplication. We have times, which is probably the most common one. If you see multiplied, sometimes it'll even say that, multiply. And then, as far as division, we have divide, split. So if you were split into groups, you would be divided into groups, or sometimes you'll see per, which has to do with division as well. So that's that. Those are words that you'll see throughout these problems that will help you see what we want to, what it's asking you to do. So to solve story problems, we are going to ask, what do you need to find? So in all of these problems, it will say, write and solve an equation to find the original population, or to find how much was on the card originally. So we're going to make this your variable. And so that's a letter. You're going to make that your x, or maybe in this case, original population, you could have a P stand for population. I wouldn't go with O for original because that looks like a 0. And then on the card originally, you might say C. You could use really any letter that you would want, as long as it doesn't look, that's a Z on the end. Any letter that you want, as long as it doesn't look like a number. And then after that, you're going to write an is sentence. So if you think back to our equations, we always had an equal sign. And so that's what equals, if we translate that to English words, normally it's is. So the new population increased by 5, and now it is 25, might be an example of that. So write an is sentence. So far we have a variable and an is, and then we'll see what other words come into play in the equation, in the examples. So at that point, we've translated the variable and the equal sign, and now we're going to translate the sentence into mathematical language. So writing down what's happening to the variable and what that equals in order to search for the variable. So you'll see what that means a little bit more once we get into the examples. So Example 1. Over 20 years, the population of a town decreased by 275 people to a population of 850. Write and solve an equation to find the original population. So I underlined a couple important things there. Also, what I notice is we've got a couple of numbers that seem to be important. And we're going to create an equation to come up with whatever original population is. So we could say X for that, we could say P, we could say really whatever we want. I'm going with P because we have population there. So we take our original population, and we know that over 20 years the population decreased. So what does decrease make you think of? Subtraction. So the population decreased by 275 people. So if I take my original population and that decreased by 275 people, wouldn't that equal 850? To a population of 850. So I think that this is well translated into mathematical language. So the population minus 275 is 850. So that's my is sentence that I could translate. I could have written that out in words. Population minus 275 is 850. So now we've got to use the inverse of subtraction, because P minus 275, we have to do the inverse of that. So we're going to add 275 to both sides, plus 275. And so P minus 275 plus 275 is just going to leave me with P, so the only other thing I have to worry about is this 850 plus 275, and we get P equals 1,125. And that's my answer for that one. Alright? So, these are the steps to follow, 1 through 4. Let's try the other one. So Tara got an iTunes gift card for her birthday. She did not know how much was on the card, but then when she added 15, her new balance was $35. Write in, solve an equation to find how much was on the card originally. So that's what we're looking for. How much was on the card originally? So I'm going to go ahead and make that my variable. C for card. Other important things, we saw added, so that means there's addition. So the original card, she took the original card and added 15, and her new balance is 35. So the original card plus 15 is $35. So that would be the equation that you'd come up with to figure out what's on the card originally. We still don't see that clearly, but once we solve the equation, we'll be able to see clearly what was on the card originally. So C plus 15, if I want to get C by itself, I'm going to subtract 15 from both sides. So minus 15 from both sides of the equation. And we have C plus 15 minus 15 is C, equals 35 minus 15 is 20. That is how much was on the card originally. And it makes sense. So if you take a card that has $20 on it and you add $15 to it, you're going to end up with a balance of $35. So, yep, C equals 20 would be an acceptable answer for that one. We'll go over more examples. And then you'll start to see homework problems that sort of mirror these examples.